A simple pendulum, 50 centimeter long, is suspended from the roof of a cart, accelerating in the horizontal direction with constant acceleration √3 g meter per second square. The period of small oscillation of the pendulum about its equilibrium position is. We have given four options. First, I'm going to tell you the strategy of this question, or you can say the strategy of solving this question. Such type of question you must have studied in Newton's laws of motion. So what is the strategy? Just understand this. At any moment, if you understand the strategy, then pause the video and try yourself. So normally, when we find time period of a small oscillation of the pendulum under non-accelerated frame, like in this question the cart is accelerated. If it is not accelerated, a simple pendulum will oscillate about vertical line. Is that clear? This pendulum will be in vertical direction and it will oscillate like this. This is the vertical line. It will oscillate like this. But in this situation, because we have accelerated cart, so it will oscillate about its new equilibrium position. So first we have to find the new equilibrium position. So for finding new equilibrium position, you can enter in the frame of this car. Suppose this is observer and he is standing in the frame of the car, and because observer is accelerating in forward direction, so he will apply a pseudo force in backward direction, like MA will be the pseudo force, and weight of this simple pendulum will act in downward direction, mg. So resultant of these two forces you can find very easily, the resultant of these two forces. So this will be the resultant of these two forces, and this pendulum now oscillates about its new equilibrium position. This is new equilibrium position and it will oscillate like this. This will, so I will show it properly. This will oscillate like this. So this is the new equilibrium position. So at this new equilibrium position, find the value of G, and that value of G is known as G effective, mg effective. So you can find very easily this G effective. So to find G effective, you can use this equation mg effective, because these MA and mg are perpendicular to each other, and this mg is the resultant of these forces. So you can calculate like this: m will be outside the bracket and a square plus g square. So I hope you understood this thing. We have used the resultant of the vector formula. This is resultant and these are the component vector. So resultant will be under root of ma square plus mg square, and you will get g effective. So this m will cancel out and the value of g effective will be under root a square plus g square. G effective will be under root a square plus g square. Now in this situation, the formula for time period will be t is equal to 2 pi, so under root L upon G effective. So if you understood this strategy, then try to solve this, and if you feel any difficulty, then see the further solution. So just find the value of G effective. So G effective will be A. What is the value of A in the question? It is oscillating with √3 g meter per second square. So this will be A square, that means 3g square and plus g square. So you will get 2g. So this is the value of G effective, and length of the simple pendulum is 50 centimeter, that means half meter. So half meter is the length. So put all these values in the formula of time period. So that is 2 pi under root L upon G effective. T is equal to 2 pi, under root L is half, and G effective is 2G. G effective is 2G, and it is given in the question. You can take g is equal to pi square, sorry, you can take g is equal to pi square. So it will be 2 pi, and this will be 1 upon 4, and g is equal to, you can take pi s square. So pi will come outside. Now it is very easy. You will get t is equal to 1 second. So 1 sec is the answer of this question. So let's see which option is correct. Obviously A is correct.